Hello students, welcome to Vedantu J English. I am Diksha Kaushal, your chemistry master teacher. So everybody, let me know in the comment section and chat box if I am clearly visible and audible to all of you. Right? Is the voice clear? Am I clearly audible to you? I am clearly visible to you? Then let me know in the comment section because we are going to do top 15 kind of questions. Okay? In these 15 questions, you will not see even a single concept that is repeated, right? You will not see even a single type of questions that are getting repeated. Ma'am, first is also sequence, second is also sequence, right? In every question, you are going to learn something new. Now, another question is, ma'am, are these previous year questions? So, no, these are not the previous year questions, but these are the questions that are designed from the previous year question from our book, that is Rank Accelerator book, right? Okay, so now let us start these questions. I have specially selected these questions just for you. And one more thing to all of you, maybe some questions you might get stuck in, doesn't mean you have to be like, I know nothing, right? Some question maybe you'll be easily able to answer, right? Okay, now the idea of this session is not to count your marks or to get demotivated. The idea of this session is to understand what kind of questions they ask you. Side by side, I'll also tell you the important topics from where they're going to ask you the questions. Okay, so if you're ready for this, then advance and plans for advance. Okay, Tajit, so it is there at 6 p.m. Okay, I'm going to take a one session live only. I'm taking because in live you can also ask me your doubts for organic chemistry, right? So that session is basically for the students who are right now confused about what exactly to do in organic chemistry. Why I took this session first and then I'm going to take that session, there is also some strategy behind that, because right now I want you to actually understand what kind of questions will be there, right? If you find that, ma'am, I am finding problem in solving these questions, then solution is also there in 6 p.m. lecture. But firstly, you have to identify what is your level for JEE Advanced. Then, if you know the level, I'm going to tell you the solution in the next slide, where we are going to have the solution for this one, right? Okay. So, the first question on your screen is regarding EZ, right? So EZ and RS are very rarely asked in JEE mains, but they are very frequently asked, especially RS and EZ are very frequently asked, even capital D, capital L, right? So very interesting questions are asked in these three cases, right? Okay, these three isomers, right? So first is going to be, now they have given you some compound, assign double bond configuration to the following, okay? Now remember, this is according to CIP rule, that is Carl, Ingold and Prelog rule, right? Okay, so CIP rule states that you have to give the priority, okay? Let's say I'm assuming you know nothing about CIP rule, okay? So CIP rule means you have to know the priority. So for example, there is hydrogen, because hydrogen has lowest atomic number, right? That is why the priority will be least here, right? And let's talk about, you have hydrogen and chlorine and fluorine. In this case, this will be first priority, then second, yes. This is first priority, this is second, this is third. Nahi, ulta. First priority, second priority, third priority. More atomic number, more is the priority. So this is 9, this is 17, so atomic number, this is largest, right? Now, ma'am, what if I have isotopes? So what if you have same atomic number? In that case, what if you have hydrogen, deuterium and tritium? In this case, this is going to have first, this is going to have second, this is going to have third priority, right? Now, based on priority, two kind of questions we have. One is RS, other is EZ, okay? So what we are going to do in EZ? EZ means you will have a double bond here, and to the one side of double bond, you will assign the priority. Let's say this is first priority, this is second priority, this is first priority, this is second priority. Now, according to that, you will answer whether it is E or Z, right? So, how to remember that? Just remember E for enemy, okay? And enemies are always on the same side or the opposite side. Enemies are always on the opposite side, okay? So, enemies are always on the opposite side here. That is why For E, you will have 1, here you will have 2, here you will have 2, here you will have 1. This is a E configuration. Okay, but ma'am, if we talk about Z configuration, that should be 1, 1, 2, 2, or it can be 2, 2, 1, 1. That will be your Z configuration. That is same configuration, right? Okay, right? Now let us solve this. Let us solve this question. Every concept I have told you regarding JEE, this EZ configuration, right? Now here, firstly, let us talk about these two things. This is carbon, this is carbon. Now you have to go one step, one step. You have to look for one atom, then you look for other 3 atoms. So now if you see this, very important, this is carbon, this is triple bond N. Okay. Now, if you go to this carbon and this carbon, and both are same only. When both carbons are same, then you will cancel these carbons with each other. Now you have to look for the other atoms that are linked to this carbon. Now always remember a single bond. Let's say you have C single bond N. You have C double bond N. You have C triple bond N. So single bond means you have just one single bond with N. Double bond means here you have 2N. Triple bond means you have here 3N. Okay, that is how you're going to answer this. What if you have CO single bond, CO double bond, CO triple bond? That is how you're going to answer that, right? So if you see this, you can also write it as this is C, 1N, second N, third N, because it is C triple bond N. And this carbon is linked to 2 hydrogens and 1 nitrogen here, right? This carbon is linked to 3 nitrogens. Now you tell me which will have the more priority. Ma'am, see, this carbon and carbon is same, so it will cancel out. Now we will see it is attached to 1 nitrogen, 2 hydrogen. It is attached to 3 nitrogen. So nitrogen will cancel out. Now it is attached to 2 nitrogen, it is attached to 2 hydrogen. So definitely 2 nitrogen has more priority. That is why we are going to say that this has the first priority, this has the second priority. Is that thing clear to everybody or not? This has first, this has second, right? Talking about this, now I'm going to do things fast here. Now this has 3 nitrogen, right? This has 1 carbon. Carbon is connected to 1 hydrogen and 2 carbon. 1 carbon here, 1 carbon here. Again, we know that nitrogen has more atomic number, so definitely the priority of CN will be more. So this is first priority, this is second priority. That means they are opposite to each other. Opposite means E is the configuration. That means these two are eliminated. Either A, either C can be the correct answer. C has high chances, but still, because they are asking about a configuration of the following. So here you have 2 bonds, okay? So that is why you can't say just E. You have to say E, right? So that is why answer is directly that C is the correct answer. But still, we will look for the double bond here also. How we are going to answer the EZ configuration here, right? Okay. So if you see this carbon here is attached to this carbon here. Wait a minute, is attached to 1 carbon, okay, right? This carbon is attached to 2 hydrogens and 1 carbon here. This is also attached to 2 hydrogens, 1 carbon here. Then this is further than these. This means these two are same only, it will cancel. Now, the point of differentiation is this carbon. This carbon is attached to 2 hydrogens and 1 carbon further. This carbon is attached to 2 carbon and third is also carbon, right? Wait a minute. This is attached to not 2 hydrogens. This is attached to, wait a minute, these two are similar now. So this is attached to 2 hydrogens and 2 carbons. Right? So this carbon is same only. This is attached to 1 hydrogen here, 1 hydrogen here, and 1 carbon here. Again, the carbon is same, right? Now we know that this carbon is a double bond. That means this will have the more priority. That means here it will have more priority, here it will have less priority. Okay, you have to look for the point of differentiation here. Now, if you talk about this thing here, this carbon is attached to 2 hydrogens and 1 oxygen, CH2O. This is attached to C double bond O. It's like this, na, C double bond O. That means it is attached to 3 oxygens, right? So definitely that is going to have the first priority because that is attached to 3 oxygen. This is attached to 2 hydrogens and 1 oxygen. So 3 oxygen has more priority. So answer will be, this is also E because that is also opposite. So answer is going to be E is the correct answer. So C is going to be the correct answer. E configuration, E configuration. Is that clear to everybody or not? Is that clear to everybody or not? Right? I see students disappearing because yes, ma'am, we are not going to see anything which is useful for us. Right, ma'am? Give us easy questions for JEE Advanced and make us believe that those questions will be there in JEE Advanced. No, I'm not going to fool you like that. Right? So yes, these kind of questions will be there in your JEE Advanced. You have to practice this if you think that I want to crack JEE Advanced. Otherwise, it's not possible. It's not that easy, right? Okay, it is easy, but you need to follow. You have to do these topics. It's not a very tough question. The question was very easy. But if you know the concept, then the question will be very simple for you, right? Next is DL configuration of the above carbohydrates. Now, what students usually do in hurry, they'll like, okay, ma'am, DL configuration, very simple, ma'am. Okay, ma'am, this is on the left side L. Okay, ma'am, this is on the left side L. Okay, ma'am, this is, ma'am, there is no, I don't know, right? That is how students answer. Okay, LL is here, so answer will be, this is the correct answer or this is the correct answer. And that is exactly a wrong method of answering DL configuration, right? Okay, so now let us see how to answer this. First, you have to see one thing, that whenever we are making Fisher projections, whenever we are making Fisher compounds here, you should know one thing, that if you're, this is your Fisher compound, here it should be one oxidizing group. Oxidizing group here, right? Like CHO, COH should be here, right? The one which is more oxidizing, right? So that is why CHO should be here. CHO should be here. Here CHO is there only, right? Okay. So how we are going to interchange it? Let's see that. First thing is how we are going to interchange. First thing, we are going to take up here. It's like I have a book like this. It's like I have a book like this. I'm going to rotate it like this. Okay. I have this book. I'm going to rotate it like this. The same way we are going to rotate this molecule. Okay. So this is the molecule. When I rotate it here, see, when I will rotate it here, I know my OH. What kind of configuration will be formed here after rotation? When I'm going to rotate it, wait a minute, let me see. So what kind of configuration will be made? So if I rotate it like this OH will be on the left side over here. This OH will be on the right side over here. This is this OH. And CHO will go above, CHOH will go down. Okay, so that is how you're going to rotate it to 180 degree. Now you can see L and D configuration, that is according to, if the last chiral carbon, you have OH on the left side, it is L configuration. So OH is on the left side, so that will be L configuration, right? That means for first you have L configuration, that is done. Now this also you have to rotate it. This also you have to rotate it. Both will be on the right side. This will be on the left side. And this will be CHO is on the up side and CH2OH will be down here. So it will be CHO, HOH, HOH, CH2. This is how you're going to rotate it to 180 degrees. Okay. And hence, here you can see OH is on the right side. Okay. OH is on the right side. Right side. Just remember DR. Okay. DR. Doctor. You can remember DR. Doctor. Diksha Ma'am is always right. Okay. DR, whatever you want to remember. Right. So this OH is on the right side. So that is your D form. Capital D. I'm not talking about small d, small. That is different. Right. Now talking about the last, this one here. Right. This is LD. Let's see if by LD you can solve this. LD, you can see these two things. Still you have to solve it. So by elimination, usually in JEE Advanced, you won't be able to solve questions just by elimination, right? You have to know the concept thoroughly. So if you see this here, you can't rotate it because you need CH2OH here, right? See one thing, if you do odd exchanges, then the configuration will change. If you do even exchanges, then the configuration will remain the same. That is why I'll firstly replace this to this position, right? Then it will become CH2OH here, and here you will have OH, and here you will have H. Then I am going to, wait a minute. This is the odd exchange. Now I want even exchanges. So what I'll do, I'll firstly exchange these two things because I want even exchanges. If you say that, ma'am, this is exchanged by this, now you write DLN configuration, that will be opposite of what it is originally. I need even exchanges. So I'll replace this hydrogen with this OH. So that will be, this is OH here, this is H here, this CH2OH is same, right? Once I do one odd exchange, then one more exchange means this is replaced by this thing. So now it will be, this is OH as it is, here it will be CH2OH and this is H. Now you can see in the last chiral carbon, OH is on the left side, that means it is L configuration. So answer is going to be LDL is the correct answer. Is that clear to everybody or not? Right? Is that clear? Okay. So B is going to be the correct answer here. Right? B is going to be the correct answer. Right? Now this question was not at all lengthy. Right? Not at all lengthy. And these, you know, in JEE Advanced, it's a very misconception that they will ask you something out of syllabus, something very weird. Like, no. Right? They will ask you from the topics that they don't usually ask. Right? From DL configuration, RS, and then EZ, then mixing of the concepts, right? These kind of questions that they frequently ask you, right? So that is why you have to master by solving a lot of questions. Just by going through the theory again and again will not make it. You have to solve a lot of questions, right? Okay. Next is, which step is used to produce 1-chloro? Now the question is 1-chloro 3-ethyl benzene. Okay, so 1-chloro 3-ethyl benzene means what? That means this is benzene, one position is chloro, third position is C2H5. This is what you have to make here. Okay, this is what you have to make here. Talking about the first thing here, it is going to give you CH3COO electrophile here. Okay, it is going to attack here, so it will give us on benzene. See, for this there is no shortcut. You have to answer, you have to make all the reactions here, right? So this is first, here you have C double bond O CH3 electrophile. Then you have Cl2Al Cl3, right? That means that is, here you will have Cl positive electrophile and it is going to attack on meta position, right? Why? Because C double bond O is minus I effect it shows, so that minus M effect it shows, that is why it is a meta directing group. So here you will have Cl, after this Cl will be on the meta position. Then you have zinc amalgam. Now what is this? It is Clemenzin reduction, right? So now you will convert this C double bond O to CH2. That means, am I able to make this compound? Yes. From first only we are able to make this compound. That means A is the correct answer. Now, ma'am, from the second one, why not? Because here what you will have firstly chloro. And chloro is a ortho-para directing. Then you will have this CH3CO electrophile on the para position, right? And then you will be able to make, instead of this 1-chloro, you will make 1-chloro 4-ethyl benzene. But you need to have 3-ethyl benzene, that means on the meta position. That is why this is eliminated, right? So rest of the questions are so different only, right? Okay, different only. So you will find it very difficult to have CH3, Cl2, CH positive electrophile firstly, right? Then that again, it will be orthopara, right? This will be orthometa, but you will not have that CH3, Cl2. So this is the only way where you can make this compound. So answer will be, firstly you will have Friedel-Crafts acylation, then you will have then you will have chlorination, then you will have Clemenzin reduction. What is this? This is Clemenzin reduction. Clemenzin reduction. Okay. Next question on your screen is, okay, A is the correct answer. Now next question on your screen is, Very interesting. Now in JEE Advanced, if you see na, in JEE Mains, hardly they will give you very rare question in which they have asked you stereochemistry. But in JEE Advanced, the focus is on those topics only. Stereochemistry, like the change in configuration, inwards, outwards, right? You should know the mechanisms, which is going to have the syn attack, anti-attack. All these things are very important for JEE Advanced, right? So here, that is not useful in JEE Mains. JEE Mains, they ask you very direct questions, okay? So now, this is one of the direct questions. So I'll tell you, in JEE Advanced, they have 2-3 kind of questions. One question is where they will ask you multiple concepts, right? Other is they will ask you direct question. This is a direct question, but here, this direct question also they are asking you very interesting, not a simple reaction they are asking, right? So here you have KOH in acetone. Now we know that KOH in acetone is going to replace Br with OH, right? Okay, Br will be replaced by OH, right? So, if you see this is cis, now they are asking you in the product, will it be cis or trans? Now what you will see that in the product, because this is KOH acetone, then the configuration, the stereochemistry will entirely change. And let me just show you. Br will be replaced by OH, but with a solid wedge. H will be then turned out to be a dash wedge. The stereochemistry will automatically change here. Okay, what you will see, wait a minute. This was in solid wedge, now this will be in dash wedge. Sorry, oppositely I told you. Yes. That means stereochemistry will be opposite basically, right? I thought that was in dash wedge. So this is in solid wedge. This will be converted to dash. This will be converted to solid, right? So this is what you will see by attack of KOH in presence of acetone. That means stereochemistry has changed. Now talking about the answer here, if you see how to answer this, you know one thing, 1R and 3S. This is what they are saying. Cis 1 bromo 3 methyl cyclohexane. So first thing is it will not be cis anymore, it will be trans. Why? If you see two hydrogens, they are on the same, that means they are both on the dash edge, dash wedge. That means they are like this. Okay, so that is trans. That is cis. If they are like this, they are like this. One is this way, other is this way. They are opposite to each other. Let me just draw it here. Let me just see if I have anything. Chalo. Let me just draw it like this. Okay. So here you have, this is actually not a very good pen, right? So here you have, this is H, this is H. If they are on the same side, that is cis. If they are on the opposite side, like this, right, they will be called as trans. So now, in this pair, this is dash and this is solid. That means this is going to be trans, right? Next thing is, ma'am, this is 1S, 3S, this is 1R, 3R, right? So see, one of the configuration will change here, right? One of the configuration, if you are saying 1 bromo 3 methyl, so this is 1 bromo 2 and 3, 4, 5, 6. That means this is the numbering that you have done. Now you are saying 1 is R and 3 is S. Now after this we know that nothing has happened to the third position. So that means on the third position you will have S only. So in third position you will have S only. But in this position is going to change to S here. It will get reversed because the stereochemistry is opposite here. So it will be 1S. So answer will be C is the correct answer here. So answer is C, that is 1S, 3S trans 3-methyl cyclohexanol is the correct answer. Is that clear to everybody here? Okay. Extras, labels, surface chemistry, states of chemistry. Okay, Mahindra, I'll look into that. Okay. Okay. Yes. See in your comments. Ma'am, please look into the comments. Okay, students, I'll look into the comments also. Yes. Is that clear to everybody or not? Is that clear, students? Let me know. Till here, if you have any doubt, whenever I ask you till here any doubt, then just directly write the doubts in the comment section. Till here, if you have any doubt, let me know in the comment section, students. Right? Okay. Now, next question is the compound C. Now, this may, when you will see in the exam, you will be like, ma'am, such a scary question. Ma'am, what is this? Now, might be some students might fail to answer this, right? But this question, if you know 1, 2 things here, then you will be able to answer this, right? Okay, let us see how. First is 2, 3 hints, very basic hints of chemistry, right? In JEE Advanced, again, I'm saying they will ask you from a very core chemistry concept will be asked, right? So here it is HMU, you will get scared of this thing, ma'am, what we have to do here, right? First thing is you should be clear that whenever you have help, HELPR, that means heat, electricity, or light, or any peroxide, or any free radical itself, then it is going to give you free radical mechanism, right? So here you have light, that is HMU, that means it is going to generate free radical electrophile, that is C free radical. Now, the question is where this free radical is going to attack. Okay, that is the question, that where this free radical is going to attack. So how many positions? So free radical usually attacks on the benzylic or the allylic positions. Okay, so here you will see if this is double bond, this is single bond, then it can attack, this is double bond, then single bond, to this position it can attack, right? To this position it can easily attack here, right? Then you have NBS again. NBS means N-bromosuccinimide. Here also you will have Br free radical. That is also going to attack on the allylic or benzylic position. You have to find that. Then there is KOH, 1 mole, and you are heating it. That means this is going to give dehydrohalogenation. Halogenation. The halogen that you have given here, it is going to, we are going to take that hydrogen from that position, right? So these are the few things that we are going to do here, right? So first is Cl free radical, then Br free radical, then KOH molecule, where it is going to dehydrohalogenation. It will try to take out that halogen in which it is easy, right? In which it is easy to take out that hydrogen, right? So once you see this, first is the Cl will attack on which position? You have this position, you had this position, right? This position was also 1, 2, 3. This position was also 3 degree, right? This was also benzylic, this was also benzylic, right? Okay, but here what you can see is a formation of a cyclohexane ring. So firstly it will choose this position, right? That is why firstly it will not choose this position, right? Firstly it will choose this position here, because both the conditions are same only, both are benzylic, carbons, everything is same. Here it is open chain, here it is ring. So first free radical will attack on this position. Then the second free radical will attack on this position, okay? So now you have 2 free radicals. Now that already have formed the bond in this, right? Now you have dehydrohalogenation. Now the main thing is, should halogen be taken from this side and you should make a double bond here, or you should take out halogen from this side and you should make a double bond here, right? So if you see this, a double bond in a ring will be more stable rather than in the open chain. So that is why double bond here is formed. That means Br negative is taken out, hydrogen is taken out here, and hence you will have dehydrohalogenation. That is, your answer is going to be A is the correct answer here, right? So first thing is you should know the knowledge of reagent, okay? Second thing is you should also know that which is basically a GOC concept, okay? So which is going to be more stable, because both the positions were same. Then you also have to choose which dehydrohalogenation is going to occur here, right? So these are 2-3 things that you have to do here, right? Okay. Next question is, next students, next let us see that. Yes, okay. Sambhav, you can write it down in the comment section after the class, okay? Comment correct statement for product of following reaction. So now again you have Cl2 at 500 degrees Celsius, right? So you can say at a very high temperature it is right? So definitely it is going to form free radical here, right? Free radical. And it's not like the question is very tough. The question is very simple. The statements you have to go through. 4 different products are formed to optically active. See, there is a reaction and they have mixed with the reaction 4 different products optically active. They are asking you, they're also asking you one more reaction, that optically active compound that you have formed here are also formed by this reaction. The reaction path is free radical substitution. So all these questions they're asking, correct statements they are asking you, which of the following is the correct statement here, right? Okay. So that means it is a multiple answer question. Okay. You have to choose 1, 2, 3, 4. How many of the statement is correct? So now if you do this, we know that it is a free radical substitution. So that is clear to us that definitely Cl free radical is going to attack somewhere, right? Now, this is benzene, and here also it can form free radical. Here also it can form free radical. If it forms free radical on this position, right? On this position, we know that in this position, free radical will be very stable because of this allylic conjugation and this benzylic conjugation here. So, free radical is definitely stable on this position, right? But we know that there will be conjugation here as well. We know that whenever you have C double bond C free radical, then it is converted to C free radical C double bond C, right? So that means here you had pH, here you had pH. It can also be converted into this thing. So out of these two things, you will have the formation of compounds here. Let us see how many compounds. If you see, the free radical is formed that I have already formed for you this. It can do resonance like this, right? Okay. From this, if you add Cl free radical, this is the compound that is formed. Okay, right now don't look into this, what is an enantiomer, just ignore that. If you add Cl on this resonance structure, then you will have Cl like this. Now, those students who know just till here, they will be like, ma'am, 2 are formed, 2 answers are formed, ma'am. So this statement is incorrect, right? But this statement is actually correct. Because here they are not only asking the just reaction, okay, they are also asking you the isomers, everything, right? So if you see this, we know that this is a chiral carbon. So whenever you have a chiral carbon and it is a asymmetrical molecule, right? We know that what is optically active compound, which is asymmetrical and which has a chiral carbon, chiral center. So that means this is optically active, right? It has a mirror image which is non-superimposable to it. So that means you can have 2 enantiomers here, right? So this compound can exist in one more thing, that is the enantiomer of this compound. So 2 compounds already are formed in this case, right? What about this one? Here you have a double bond. So double bond, you can have H and H on the opposite position. This can give you trans, and you can have H and H on the same position. This will give you cis. That means again you have 2 geometrical isomers. So students, you have 2 optical isomers, 2 geometrical isomers. That means total 4 kind of compounds can be formed from here, right? Total 4 compounds can be formed from here. So definitely this is your correct answer. This is your correct answer. 2 optically active compounds. Yes, you have 2 optically active compounds are formed here. That is also correct. The optically active compound formed here can also be made by the reaction of HCl. So now HCl means you have to form a carbocation here, right? Okay. So carbocation can be formed here. We know that this bond will break here. Wait a minute. This is where we have that. This was the compound, right? Okay, so now what will happen? Either this carbocation can be formed or this carbocation can be formed, right? We know that this carbocation is 1 degree, this is 2 degrees, so this is more stable. So we will form this carbocation. That means pi electrons will shift here and you will have this carbocation that is 2 degree. Now once you have this 2 degree carbocation, you know that what will happen? This is a 2 degree carbocation, right? Okay. Now, if we shift hydride to this position, one more concept here, that is rearrangement concept, rearrangement of carbocation. So that is how JEE Advanced questions are. There are so many concepts in just one question, okay? So here what you have, hydride shift, right? That means this hydrogen is shifted to this side, and here you have the carbocation. But ma'am, why? What is the need of hydride shift? Because here you don't have any resonance. But in this case, this C positive and this is the phenyl, right? This is going to show resonating structures here. That is why this carbocation is rearranged and that is more stable. Then you add Cl negative. This is the compound that is formed, which is a chiral carbon, and hence it is optically active with two compounds, just like the same compound is formed. So that is also the correct statement here. So formed here can also be made by the reaction. The optically active compound formed here can also be made by the reaction of HCl. Yes, that is true. Then all the statements will be correct, right? Because we have formed it by HCl also. CH3, Ca, no. No, we have not formed it by HCl. The same compound, have we formed the same compound? No, right? We have not formed the same compound, right? We have not formed the same compound. This compound and this compound, both are optically active, but they are not same. This is CH2, double bond CH. This is CH3, CH2. So they are not the same compound. If they ask you optically active compounds can also be formed from this, then that is true. But here they are saying the optically active compound formed here. What is formed here is not formed there. So this is the incorrect statement. So answer will be A, B, D are the correct statements here. Is that clear to everybody or not? Right? Okay. Right, everybody? Is that clear or not? Next we have everyone in the comment section. Is that clear? Now we are going to start with next question here on your screen. If till now you have any problem, then let me know in the comment section. Right? Okay. What is odd and even exchange? So if you exchange something just one time, that is odd exchange, right? Odd number of times. If you exchange the compounds, interchange them even number of times, that is even exchange. In odd exchange, the configuration will change, right? R to S, S to R. But in odd exchanges, that will not change. Okay? Right? Okay? Yes. Now, next question is, we will definitely take that entirely depends upon your response. Students, what is your response? Depending upon that, I'll take the classes. Right? Okay, if that much hard work we do for you and we get nothing in return, right? No response, no appreciation, then definitely our motivation also is not appreciated after that. So our motivation is also then sometimes disbalanced, right? Because of that. So yes, that totally depends on you, right? So compare the properties of two isomeric products X and Y formed in the reaction. So now this is a very interesting question. Okay, so you have phenol. We know that. Okay, tell me CCl4KOH. CCl4KOH. CCl3 is remer temer reaction. But what if I told you that CCl4 in KOH will give you salicylic acid? CCl3. If you have CHCl3 chloroform with KOH, that will give you salicylic aldehyde. But here it is going to give you salicylic acid. We know that there will be one ortho, that is this thing, and one will be para. But the amazing part is they have not told us which is X and which is Y. We have to assume that and we have to see which fits into which. That is the main important part of this question, that here they have not confused you with the question. This part is not confusing at all. This part is confusing. The option part is very confusing. So high chances are some students can get confused in the options only and will mark the wrong answer. Right? So you have to be very clear. I'm taking this as X and this as Y. Maybe I will not be able to match any of the answers. Maybe I will be, right? So now firstly, let us see which has more acidic strength. So Y greater than X in my case is not possible because acidic strength of, because here it is going to form hydrogen bonding. So that means acidic strength here should be greater. X should have greater acidic strength as compared to Y, right? So for me, A and C are eliminated, right? I am taking X and Y. You will say, ma'am, take Y as that, X as that. We will also solve with that, right? Firstly, this is X, this is Y. Usually it is ortho in para written. That's why I'm taking it like that, right? So now I'll see the solubility. See, if you see this here, the solubility of Y is greater here as well. Okay, this one here they are saying X is greater and Y is greater, the solubility, right? So solubility means in water, right? What is the solubility? So here OH is already having hydrogen bond with this one, right? So intramolecular hydrogen bonding is happening. That is why intermolecular hydrogen bonding will not be that much. In this case, it will be more. So Y will be more soluble as compared to X. So Y should be more soluble. So this is also eliminated. In my opinion, according to this, I'll now also see, it's not like I'll just tick D as the correct answer and move ahead. No, then I'll be doing using the wrong method. See, they have not clearly told me what is X and what is Y. I am assuming that X is ortho. So I also have to see whether volatility and melting point are also matching here. So volatility means the vaporization. So here it is forming hydrogen bond. So break this bond and make it vaporize is difficult, right? Okay. So here X will be yes, because it is not very hydrogen bonded with the water. So to vaporize it is very easy. Ortho are always steam volatile, right? Ortho products can easily be volatile. You have also read this in qualitative quantitative analysis that ortho products are steam volatile because there you have intramolecular hydrogen bonding. So X is definitely greater. Melting point of Y is greater because it is more symmetrical. That is why melting point of Y is greater. So D will be the correct answer. Now, ma'am, what if some student has chosen that, okay, you take, now tell me firstly one thing, by taking X as this and Y as this, are you able to understand how come D is your correct answer, right? Now, I will choose opposite. Now, what if some of you, let's say some of you who wants to choose Y as this and X as this, okay? Y as this and X as this, let's see what is going to be our answer now, right? So now we know that Y should be having greater acidity as compared to X. So Y should have greater acidic strength. That means these two options are already eliminated, right? Solubility of X should be greater. Yes, X should be greater. That is over here. So that is also eliminated, right? Then we have volatility of which is greater. Volatility of definitely the one that is having ortho hydrogen bonding, that should be greater. So Y should have greater volatility. Yes. Melting point of Y is greater. No, melting point of X should be greater than Y. That means when I choose Y as this and X as this, you will not be able to conclude any of the answer, right? If you choose Y as this, X as this, none of this will be your answers. That is why you can't say, ma'am, they have not given us what is X, what is Y, right? So that is how these kind of questions, right, where you might be like, okay, I'll take Y as this, X as this, then you solve this, you will take C as the correct answer. You will not see volatility and melting point. That is wrong. X is this, Y is this, right? Okay, that is clear to everybody or not? Everybody? So as you can see, I am not repeating even a single concept, right? Not even a single concept I am repeating, right? Okay, every single question you are learning something new. Yes, that is this we have done. Okay, so every single question you are learning something new here, right? Something new regarding the question, something new regarding the type of question, or something new regarding the concept here, right? Okay, right? So now let us see the next questions here. This is sequence based question. Okay, so this is, you have Grignard region that is reacting on a carbonyl compound, then you are doing hydrolysis, then you have Markovnikov addition, Then you have again Grignard reagent is formed. Then again it is acting on a carbonyl compound. Then you have D. Again you are doing Markovnikov addition. That is the sequence of this reaction. Okay, understood? Sequence of this reaction. So we will try to understand what will be the correct answer here, right? So first is okay. So first is, if you see this, now this is a Grignard reagent. We know that this is positive, this is negative, this is positive, this is negative. It will attack here, electrons will jump here. So that's why here you will have OH and this will be CH3. Is that the thing that we have formed? Yes. OH and CH3, right, after hydrolysis, right? Then you have HBr. HBr is usually, if you are directly adding, see there are two concepts of HBr, right? If you are directly adding HBr, what will happen? It is going to replace this OH with the Br, right? If you are adding it on a double bond, then it will be according to the Markovnikov, anti-Markovnikov rule, right? So you are directly adding HBr, there is no double bond here, so it is going to replace this OH with the Br, right? Now, once you have a halide here, then you add Mg ether. That means this Br will be converted to MgBr. That is converted to MgBr here, right? Now, this is your Grignard reagent that is reacting on HC double bond OH. These are the kind of questions that I think most of you will be easily able to do. It's not like all the questions will be some new concept. Some questions will be regarding very simple, regarding the general reagents that you usually use, right? So here it is, what you have. This is HCHO. This is negative part. See, this is very, very important how to form this thing here. This is very, very important. So this is HC double bond O. This is H. And this is positive here. This is negative. This negative is going to attack here. That means it will be attached by, this will be attached by, I am right now writing, this will be attached by this carbon here, right? This carbon here is attacking here, right? This carbon here, right? Then this is 1, 2, 3, 4, 5, and this is converted to OH here, right? Okay. And to this carbon, you also have one CH3 that is already attached here. So here what you have is, you have this CH2OH that is there. This is the compound that you have. Understood how we are going to form this compound, students? How I formed it. Here you had this thing. Simply what you're going to do. This is HC double bond OH, right? This carbon is going to attack here. So you will have one carbon attachment. That carbon, we know that it is pentagonal ring, and this carbon is attached to one CH3. This double bond O is converted to OH, and that is the compound that you will have here. This is written here on the pentagonal. One is CH3, one is CH2OH, right? After this, you are going to add HI. That is the last step, and hence it is the most important step here. What you are going to do? Now we know that OH bond will break here and this will be converted to HI. But the question is how HI will be donated here, right? So when you have HI here, what will happen? This OH, right? This bond will break here, right? This bond will break here. And here you will have the addition of HI, right? Okay, this bond will break here and here you will have the addition of HI, right? So here that means when you are going to eliminate this thing here, because HI is nothing, it is an acid only, like HCl, HBr, right? All these are what? These are acids, right? Okay, so this HI is also acid, though it is not a very strong acid, but yet it is an acid only. HCl, HBr, HI, HF, all these are acids only. So it is going to eliminate this OH negative from here and it is going to give you carbocation. Now, if you remember the ring expansion, I'm just gonna write it like this only, right? Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and this is CH2 positive. So whenever you have ring expansion, mark it 1, 2, and mark it 3. Okay. So now what you have to do, join 1 and 1 and 3, break the bond of 2 and 3, right? You have to break this bond. This you have joined, and now this positive is shifted towards this this 2 here. Okay, join the bond of 1 and 3, break the bond of 2 and 3, then to positive is shifted to 2, right? That is how you do the ring expansion. Why we did the ring expansion? Because 6-membered ring is more stable than 5-membered ring. Ma'am, if here already we had 6-membered ring, then will we convert it into 7-membered row? 7-membered ring is not stable as compared to 6-membered ring, right? But everyone wants to get converted to 6-membered ring. So that's why ring expansion happened here. So to write it in a better way, I know I have a ring which is like this, where on one position you have CH3, on that position only you have the carbocation. So that means when I negative will attack, that will attack on the same position, right? Hence, this is the final product that is formed here, right? Okay, from where we started, from where we landed, okay? That is how the sequence, see, when sequence reactions are asked in JEE Advanced, look for if anywhere you have rearrangement, you have tautomerism. These two concepts are what directly they don't ask you rearrangement and tautomerism, but they are somewhere hidden in the concepts only, in the reactions only. Okay, understood? Next question here. Now this I would say, this is sometimes they ask you questions from some weird reagents, okay? Then you have to look for the reagent. So this is entirely based on reagent, right? Okay, let us see this. Trust me, maybe only few of you know these reagents, right? Okay, so this is maybe a new concept, new reagent for you, right? I don't know. That totally you can tell me about it. If you know this, what is the work of this reagent, then let me know in the comment section. Otherwise, we'll start with this is a long reaction, lengthy reaction. So let us start that. Okay, and here it's not like here the reaction has stopped. It's 2-page reaction, okay? So that's why I'm saying that look for these kind of reactions here. So you have NH4 twice CO3 gives ammonia on heating, right? So we know that whenever it is heated, it dissociates and gives us NH3, right? Ammonia undergoes nucleophilic addition reaction with carbonyl, and we know that basically they have given us directly ammonia in the form of NH4 twice CO3, right? So we know that we should know that what exactly ammonia, how ammonia is going to work here, right? Okay. So let us see that. Okay. So now here you have carbonyl compound. These are two CH2 groups here, right? Firstly, we know that here in this reaction you have H positive also, because that will be released here only. So this O negative, because it is electron negative, it will going to attack here. Negative always get attracted towards positive. So this is going to attack here, right? You will have the attachment of this H on this position. Oxygen, because now it is bonded to 3 bonds, bonded with 3 bonds. That is why it is going to have positive charge here, right? Now we know that ammonia looks for, it is electron donating, it is looking for that position which is electron deficient, right? So because of this oxygen, this carbon now is more electron deficient now, right? Because on this oxygen you have positive, right? Okay, the one that was electron rich is also electron deficient now. That is why this electron deficient in carbonyl is more electron deficient now. So that is why this is going to attack here with more rate, right? And hence what you will have, it will attack here, and this double bond will shift here, and hence you will have, wait a minute, let me just write this again. You will have COH here. Okay, so this will be OH, this is CH3 as it is. When ammonia will attach here, now ammonia is bonded with 4 bonds. N only can form 3 bonds. Now it is bonded with 4 bonds. So whenever you have more bonds, then you expect, for oxygen always form 2 bonds. It has 3 bonds. That is why it will have positive. When oxygen have 1 bond, it will have negative. Nitrogen usually form 3 bonds. When it will have more bonds, penta is not possible. It will have 4 bonds, it will have positive. It will have 2 bonds, it will have negative. Okay, so here it is having 4 bonds, that is why it is going to be positive here. Now you know that this is NH3, there is a ring formation that is going to happen here. Okay, so this nitrogen is having 4 bonds and this is positive, and this oxygen here, we know that that is electron deficient. That carbonyl oxygen is like, I want hydrogen, I want hydrogen. This carbonyl, right, it had, this carbonyl oxygen had hydrogen from here. This carbonyl oxygen will also want that I also want hydrogen. Okay, it will abstract this hydrogen from the nitrogen, right, and hence you will have a double bond, oxygen positive and this thing here, and that will lead to the ring formation here. That will lead to the ring formation. Right now there is ring formation over here, right? So what you will have is one ring is formed here. So I'm going to make one line here, 1 2 3 4 5. Okay, so if I write it here like this, let's say I write 1 with some other pen I am writing. Okay, with some other pen I am writing 1 2 3 4 5 here, 1 2 3 4. So whenever you have to write do ring like ring formation, right? Ma'am, who will tell us there will be ring formation? As you can see in the options only, they are giving you one hint that there will be some ring formation, right? Okay, so open chain compound will not be formed here, right? So that is why one ring formation will be there. So 1 2 3 4 5. So 5-membered ring. On first position you have this double bond is going to shift here. This is going to get converted to OH. So this is 1, this is 2 3 4 5. Okay, so 2 3 is carbon carbon, fourth is the carbon which has CH3OH, CH3OH. Okay, fifth nitrogen is having 2 hydrogen, 1 hydrogen here, right? Okay, okay. Now this hydrogen is also taken out, and here you will have to this first carbon you have one CH3 and one OH, right? That is there. That means total this compound is formed. But ma'am, this compound is not also there in the option, right? Now, if you see this here, what is going to happen, right? Here you have one OH, right? Here also you have one OH, right? Now, as I told you, in this first case, you are adding H positive also with this NH4 twice CO3, right? So, it is an acid, means acid H positive, we are supplying it. Firstly, this acid will attack here. Then they are going to make a ring. Now, it's not like you have told acid that, okay, now don't react. Acid will still react here. It's not like in the beaker you don't have any acid left. And what is the work of an acid? To cause dehydration. That is why now this compound is apical for dehydration. Now here you have hydrogen. This is also one hydrogen. This hydrogen, this OH, this hydrogen, this OH are going to make a double bond on this position. Hence, this is the compound that you will have. But this is a very, very, very interesting and important question. Okay, right? This is the compound that you're going to have here. Now, next is, in the second step, what you are doing is you are adding CCl3CO2Na. Now, you should know the work of this reagent. On heating, give dichlorocarbene, right? CCl3COONA. Do you remember this compound? CHCl3 plus NaOH. It is quite similar to that only, right? It is quite similar to that compound only. This is how you can remember, right? Okay. So now this is the compound that was finally formed here. Now this compound is reacted with this reagent, which is going to, we know that it is going to form chlorocarbene, right? Okay, dichlorocarbene, that is CCl2. This is going to form with these reagents. Okay. So now here what will happen? Firstly, we know that here, because of this CONA, basically it is a compound that is actually basic in nature. So what it is going to do, once it is going to abstract the proton here, proton will be abstracted, electrons will jump here, you will have negative here, right? Now this dichlorocarbene is going to attack here because this is electrophile. This is electrophile, this is electron deficient. It is going to attack here, and hence now this is very, very important, very, very important, that when you have this pi delocalization, and this is electrophile, right? That is going to attack here, just like you did in Reamer-Timmer reaction. It is the same way you did in Reamer-Timmer reaction. It is going to attack here. This pi bond will break. You will have Cl that is attached here. Okay, you will have this pi bond will break, and here you will have this CCl2. Now this will be CCl. That is how it is going to form one compound here that you can see. Now what you will see in the options, there were 6-membered rings, right? Why? Because here you had expansion. How expansion happened? This chlorine will be taken out, right? Then what will happen? This negative charge basically is going to, wait a minute, let me just draw it, because this is a quite complex thing to draw, right? So this is nitrogen, this is nitrogen, this is 1-methyl, this is 1-methyl, 1CCl. Okay. So now what you will see here, one Cl bond will be eliminated here, right? One bond will shift here, one bond will shift here, and here you will have negative, this bond will shift here, so automatically you had one pi bond already. This bond will shift here, so double bond, single bond, double bond, single bond, double bond, right? Okay, that is the kind of compound that will be formed. So you will have a 6-membered ring which has alternate double bond, single bond, double bond. Sorry, double bond, single bond, double bond, single bond, double bond. Okay, so double bond, single bond, double bond, single bond, double bond, single bond, right? So here what you will have, nitrogen is attached to those two carbons which has 2-methyl group. It has 1-methyl, 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 1-methyl. Then to this carbon, one carbon is attached which has 1 chlorine. That is already here. Then that is your final answer, right? So that is, I would say, one of the most toughest questions, and I really pray that they don't ask you these kind of questions. Okay, so in JEE Advanced, it's not like all questions will be like this. Hardly one question will be like this, and trust me on that. This question why I have picked up here, right? Ma'am, do you want to scare us? No. These are the kind of questions that you should know that you should skip. Okay, these are the kind of questions. See, if in the exam you have no idea about this reactant, you have no idea about this reagent, skip this, right? Okay, there is no point wasting 10 minutes on the reaction on the question which is may or may not give you the correct answer, right? Rather than focus on these kind of questions, okay? Rather than focus on these kind of questions which you know that you can easily answer, right? So this question was I would say a question that will give you a hint that what are the questions. The question selection is very important, right? It's not like you have to do all the questions in JEE Advanced. That is, nobody asking you to do that, right? Unless and until you are a pro in organic chemistry, then you should do that. Otherwise, skip these kind of questions. That will be my advice to you. Ma'am, what advice you are giving us? Asking us to skip questions? Yes. If you feel that this question is not at all doable, this is very lengthy, time consuming, still those many marks only I'm going to get, then choose questions very wisely. Okay, right? Okay, yes. Now next question we have, let us see. Next question we have is, this is the compound. See, here you have acidic hydrolysis, right? So acidic hydrolysis, if I have C triple bond N, that is always on hydrolysis, that is converted to COOH. So this is a question that you should never skip, right? Because that is easily doable, right? So that all of them are converted to COOH, 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 COOH. Then you will heat it. Then two of this will then carbon dioxide will be released, and then water, when you heated this, yes, okay. So now let us see what we are going to do. So basically what will happen here, you will have COOH, COOH, COOH here, COOH here. Out of this, these COH will be easily eliminated, right? Okay. After that, you will be left with 2 COH, from where water will be eliminated, and hence you will have the formation of this kind of compound. I feel D will be the correct answer. Let us see that if D is the correct answer or not, right? So here what you will see, I think so, yes, D is the correct answer. So this is converted to COH, 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 and COH, right? So now we know that when you heat it, see, whenever you heat something, if it has CO2 directly, that will be taken out, because on one carbon, you can't have two acidic compounds, right? One carbon is not able to adjust two COOH groups here, right? So one should go, one COH should be eliminated from both the carbons. So that is why this COH, these two COH will be eliminated from one or both the carbons, right? Now still when you heat it further, okay, when you're not stopping the heat, you are again heating it. So we know that basically here what you have, I'll just write it in a different way so that you're able to see what exactly we are doing. So this is a very general thing that we always do, right? Okay, so this is C double bond OH. Now what will happen? Water will be eliminated here, right? And you will have COO. That means this thing will be formed here, and hence D will be your correct answer, okay? So these are doable questions and you should never ever skip, okay? Never skip these kind of questions. These are the questions that is going to give you the rank, okay? Next is again doable question, right? So you have COH here, you are adding NH3, you are adding ND3, you are adding KOD, you are adding KOH, you are adding D2O, you are adding H2O. So what is the answer that you are going to get? So these questions are not difficult. These questions are to confuse you in your exam, right? Trust me on that. All of you know all the reagents here. Ma'am, what is NH3? Students, we know that whenever you have NH3, that is going to get converted to NH2. If you have ND3, that is going to get converted to ND2, right? What is KOD, Br2, and this heat? That is Hoffman bromide degradation reaction. That means this CO will be eliminated in both the cases, isn't it? When you have D2O means you are going to, when you have this NH2 here, when you have NH2 or ND2, you're going to add D2O or H2O here. That is going to react on amine or ND2, right? Okay. So that is how you're going to have different answers here. But the main part is what will be your answer. Okay. So all of you know all the reagents, what is the work, but still you might get confused in the exam, right? Because you are in a very hurry. Arey, this question I know, I can easily do that. So don't do mistakes in hurry. So firstly we will see when you add NH3, this is NH2. When you add ND3, this will be ND2. Okay. Now here when you add KOD Br2, that is Hoffman bromide degradation, directly also you can write it, right? Okay. Directly also you can write it. KOD, KOO. This is CD2, NH2. Directly also you can write that. Okay. Sure. Now step by step they are asking you to do this, right? So step by step is first you add KOH, Br2, then heat it, then you add D2O, right? So step by step how you're going to add this, because when you eliminate, when you without any isotope, when you add Hoffman bromide degradation, you know that this is C double bond O, this is NH2, this will be eliminated, right? But here you need to know both the things you need to do, right? That means those students will be able to do who knows what is the mechanism. Okay, if you remember in the Hoffman bromide degradation, there is one step where you have the formation of RNC double bond, right? So in that case, with that compound, then further it is formed, right? Okay, so directly you won't be able to answer. So you should know the mechanism here, right? So this is KOD Br2. So in that step, what will happen? This CO is definitely as it is, and here you have nitrogen. So this is eliminated. In the first step, this is eliminated. So this is NCO. This is NCO. Now when you are adding OD, D2O, so now this D2 will be added here in place of C double bond O, and here this H2 will be added in place of C double bond O, and that is how you have ND2 and you have NH2 here. So this part is very, very, very important. These kind of questions are not at all lengthy. These kind of questions are, I would say, trick based questions, mechanism based question. You should know the mechanism of all these, this Gabriel phthalimide, Hoffman bromide degradation, Riemer-Tiemer, coal base, Dow's process, all these mechanism, each step you should know, right? Okay, understood? Next question on your screen is, next question, students, on your screen is, the major product of following reaction would be. Now, how many of you will be able to answer this? Let us see that how many of you will be able to answer this question. No chit-chatting in the chat box, students. Major product of following reactions would be, you're adding Br2 here, and first I'll give you one hint that two rings will be formed here. Right? Two rings will be formed here because whenever you are adding Br2, a cyclic intermediate is formed that is further going to split it into two rings here. Right? Okay. Even if you know that much that these two rings are formed here, even then you can just directly eliminate A and D here. Right? Okay. Now let us see how the rings are formed. Okay. Now one student has answered C as the correct answer. Okay, Gokul has answered C. Let us see how many others you are able to answer this, right? So first thing is Br2, that is going to make a, we know that there will be anti-attack here. Again, this question is from mechanism, right? So mechanisms of these important stuff is very, very important, right? Some naming reactions and mechanism of hydration, not full mechanism, nobody is asking you. At least you should know whenever you are adding Br2, there is cyclic intermediate that is formed, right? So this is the cyclic halonium ion that is formed here. We know that this is positive, so that means it is electron deficient, right? This is lone pairs. So this is electron deficient. Understand one thing, because this is electron deficient, it is going to say that I am electron deficient. That is why I am going to take up electrons from this side. So now this carbon will be electron deficient. This nitrogen is electron rich, so that is why they will form a bond here. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Both of these are 5-membered rings. So as you can see, 5-membered rings are only in this option. So answer will be B is the correct answer, right? Okay. Still, if you see this, in these two 5-membered ring, to this carbon, what is attached? Directly, you have the attachment of Br. To this carbon, nothing is attached, right? As it is, this nitrogen is on this position and that ring is attached. Okay, so answer will be B is the correct answer. Gokul was almost near. One mistake he did was that not able to understand that, okay, which attachment will be there, right? Which attachment will be there, right? So even if you see this 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. And here if you see how many carbons, 1, 2, 3, 4, 5, 6, 7. With calculating the carbons also, I am saying you, let's say you have no idea about it. Right? By calculating the carbon also, you can do the elimination that yes, this is not possible, this is possible here, right? Okay, yes students. Next question on your screen from polymers, right? Okay, that is there in JEE Advanced syllabus, right? So rest of the topics that are there in your syllabus, focus on that, because you know the differentiation between JEE Mains and JEE Advanced is the rest of the syllabus, right? So you have to go through all the syllabus, all the important points of those chapters, right? The final product of the reaction shown below on polymerization would be, right? So we know that basically what happens, firstly one polymer will be formed, and what is that polymer that will be formed? So you should know the preparation step of all these. From these polymers, very basic question will be asked here. So this is also a basic question only. You have ethyne here. In CuCl2, we know that it will get doubled here. So you will have CCH, CCH2. That means this will get doubled here. So answer will be CH double bond C, CH double bond CH2. That will be formed here, right? Okay. After that, you add HCl here. One bond will break, pi bond will break, and here you will have the attachment of Cl on that position, which has less number of hydrogens, right? So now this is nothing but this is chloroprene, right? Mostly students just do this from chloroprene polymerization, neoprene is formed, but you should also know that how chloroprene is formed, okay? So here on polymerization, you have the formation of neoprene here, right? Okay, by n number of units of chloroprene. So answer will be, answer is not D, answer will be B is the correct answer, okay? B is the correct answer. Is that clear? Okay. Is that clear to everybody or not? I think we are towards the end of the session. We are only left with only few questions here, right? I think 2-3 questions we are left with. Let me see. Yes. 2 questions we are left with, okay? Yes. Till now, we have done 13 questions, students. So we are left with 2 questions here. Among the following compounds shown below, the compound which yields different product on reaction with warm HNO3. Okay. From the rest is okay. So now they are saying that among the following compounds shown below, the compound which yields different product on reaction with warm HNO3, right? So with warm HNO3, which is a very strong oxidizing agent, what will happen? This COH is converted to COH. This is converted to COOH. This is converted to COOH. This is converted to COOH. This is also converted to COH, right? So that means CH2OH is converted to COH and CHO is converted to COH, right? That is why these are the answers. Now we have to see which is different, right? So you'll say, ma'am, all of these are different, ma'am. Let us see. If you rotate it, because see, I'll just write it the answer. So this is the first compound, this is the second compound, this is the third compound that you have. I think I have, wait a minute. So first compound had both CH. So I'll not see this, I'll just directly tell you about this, right? So here you have COOH, here also you have COOH, or I should just, for my reference, what I'll do, for temporary basis, I'll just erase this and convert it into COH, which is HNO3 is going to convert all of these into COH. Okay, so I'm also going to do the same so that you can easily understand that how we are going to rotate it. Okay, and which of the following is not similar. So if you see this, rotate this compound. Okay, if you rotate this compound, if you rotate this compound, this COH will be here, right? 3 boxes. If you rotate this, these 2 OH are going to be here. Wait a minute. Rotate this, if you rotate this OH is going to be here. This OH is going to be here, right? I am rotating this H is going to be here. And to this OH you have H. This OH you have H. This is OH and this is COH. And this is exactly the same, and they are asking you which will yield different. So here you can't rotate it. This is exactly same only. When you have both COH only, then it is possible, right? So here you have one CH3, so they are definitely not going to match any of this. So B is the different compound here. Is that clear? So that is why answer will be B is the correct answer. Is that clear to everybody or not? Is that clear? Right? So B is going to be the correct answer. That is the different product here. Last question of today, students, last question of today. Let us see that which doubt you have. So let's see, above compounds can be differentiated by using reagent. So in JEE means what they ask is direct questions on iodoform, on mild oxidizing agent, strong oxidizing agent, on aldol condensation. But in JEE Advanced, they will ask you multiple questions in one question. Okay. So that is why above compounds can be differentiated by using which reagent. So if you see this reagent, this is OH, this is OCH3, this is CH2OH. Now any of this FCl3, we know that FCl3 is given by phenol. So phenol means this is going to give you FCl3, right? This will give you FCl3, that definitely you will use. Then you have Tollens reagent in all of them. Tollens reagent in all of them. Now you have to see that Tollens reagent should be first or the second one. So if I choose firstly Tollens reagent, we know that it is going to oxidize CH2OH to CH2. This will be converted to, because this is an oxidizing agent, right? So this will be converted to CH2. This group is definitely going to show you positive test for Tollens. Positive Tollens test, right? That means Tollens, if I say this is A, this is B, this is C, then FeCl3 will be given by A, Tollens test will be given by B, okay, by C. Okay, Tollens will be given by C. Okay, now I have to choose whether CrO3 or NaOH will give any of them. So I have to see between this thing. So if I say CrO3 is a mild oxidizing agent, right? So CrO3 is not going to, I can differentiate A and B. This is not, CrO3 is going to differentiate if I say, one thing I can do here, NaOH. NaOH it will not give, sodium also does not have any benefit. So CrO3 has a benefit, okay? CrO3 is a mild oxidizing agent, so that is possible. So that means A and D or both are eliminated. Now you have to think that should you use Tollens reagent firstly or CrO3? Definitely you should use CrO3 firstly, because CrO3 is a mild oxidizing agent which is going to convert this CH2OH to CH2. Then you will see whether it is showing Tollens reagent or not. That means C is also not the correct answer, B is the correct answer. Firstly, you will use mild oxidizing agent, that is CrO3. It is not going to do anything here. It is not going to do anything there. It is going to convert secondary alcoholic group to primary alcoholic group to CH2, right? Then this is going to give you Tollens. This will not give you Tollens. This will not give you Tollens. Then you will use FeCl3. This will give you FeCl3. The rest, this compound will give you none of the test. That means that will be a B compound which is not giving any test here. So answer will be B is the correct choice of reagents, right? Yes, answer is B, which is the correct choice of reagents, which is going to distinguish these three compounds here. Is that clear to everybody or not? Is that clear, students? Is that clear to everybody that how we are going to use these different reagents here? Right now, let us see how many of you enjoyed the class and how many of the questions that you were able to answer correctly. Let me know in the comment section because I am waiting for your comments here. Right? Okay. Okay. Yes. Now, let us see. Clear, ma'am. Okay. Gokul is saying clear. Anyone of you, how many questions you were able to answer and what all you learned from today's class? What all you learned from today's class? So, basically, students, all these questions are from Rank Accelerator book only, right? Okay. I would really advise you firstly go through all the JEE Advanced previous year questions. Okay. JEE Advanced previous year questions are must to do, right? At least last 5 years that you must do, right? I would advise you to do last 10 years, right? Repeatedly you have to do. You still have 30 days left, so you can easily do JEE Advanced previous year questions, and then practice from rank accelerator book. The quality of questions I have already told you. So in this book, as you can see, none of the concept was repeated here. Every single question was very interesting. And these are the kind of previous year questions. Basically, this book is inspired from the JEE Advanced previous year questions only. So if you want to, first thing is practice JEE Advanced previous year question. After that, practice questions that are related to previous year questions. Okay. And for all those students who are actually right now totally blank about, ma'am, where we should do our revision here. So if you see, go to the live section here. This is Be a God of Organic Chemistry. Firstly, to hit the like button here, because I'm gonna join this live in next how many minutes? 30 minutes. In next 25 minutes, I'm gonna join this live at 6 p.m. right? Where we are going to see what exactly you need to do to crack JEE Advanced Organic Chemistry, right? Because if you see 30% of your chemistry, right, will be from organic chemistry, right? And easily you can score good marks, right? 30% is not a small number here, right? So you can easily crack organic chemistry, but for that, for you to utilize these 30 days properly, you need to know what kind of questions they ask you, from which part you need to study more, which are the topics that you need to study more, like how you can divide your time in these 30 days. I would give you a chart of 15 days, right? In 15 days, how you should cover your organic chemistry just in 15 days, right? Rest of the 15 days are for your revision, okay? So in 15 days, how you're going to do things in a sequence, right? That we will talk about. What are the important topics? What are the type of questions? Everything, all the problems will be solved in that session. That session is going to be 10-15 minutes hardly, right? So I'll see you all in that session. And if you see this also in this live class, right, where we are right now, so if you see this in the comments, in the description box here, you will see rank accelerator book from where I have picked up these questions, right? Okay, so if you like these questions, ma'am, will I be able to solve? Ma'am, I want to practice. So practice from a reliable source, and we are providing you this reliable source, right? So you can see for physics, chemistry, and mathematics, all these books are available at 1665, right? All these 3 books are available, right? So these are rank accelerator book, which is definitely, you can see the questions, it will open up your mind, it will open up your brain. Just doing the theory is nothing for JEE Advanced. You have to do questions. You have to do quality questions. You should not get scared of the questions. You should do, and you must do, right? If you don't practice, you won't be able to answer the questions in the exam, no matter thousands of times if you have revised the theory. It doesn't matter, right? The application of that theory is very important in JEE Advanced, right? JEE means still you can, I won't say JEE, even JEE means is possible, but JEE means still you can manage with theory, right? By reactions, by some of the practice questions. But JEE Advanced, when the concepts are entirely mixed, right, then practice is what will make you perfect, right? For that, we have this book. And if you want someone to guide you, right, in solving these questions like I just did today, right? So in that, our batch is going on. That is Eklavya JEE Advanced batch. So in this batch, basically, what we are doing is solving all the questions, previous year questions with you in the class, right? So that is full length classes are going on from morning to the evening, like to the night till 10 p.m. the classes are going, right? So that is why I'm saying, either if you think that I can do it myself, purchase the books and do it. Don't forget to do previous year questions and rank accelerator both, right? And third thing is, if you feel that, ma'am, I am very underconfident, then go through and this batch, right? So that at least someone else can teach you, guide you. At least those things will be there in your mind when you are solving the questions, which will give you a good rank in your JEE Advanced, right? So that is my advice to all of you, right? So that's it for today. Now I'll see you all at 6 p.m. for organic chemistry strategy. It's not like I'll give you some random things there. I'll give you proper schedule, proper topics, proper examples with examples. Some examples I have shown you here also. some examples I'll show you from previous year questions, that what kind of questions exactly they ask you, right? Okay. Okay then, bye-bye students, take care, and don't forget to hit the like button if you think that actually I have done hard work in preparing these questions from you, taking out these questions from your full book, right? Okay, so a lot of hard work we put into these things, right? Even analyzing the questions, right? Then seeing the same kind of questions, picking out the same kind of questions, that takes a lot of hard work, right? So it would be really great if you smash this like button, share this among your friends and your juniors as well, right? And see you all at 6 p.m. Till then, bye-bye. Take care. This is Diksha Kaushal signing off. And if you have any query related to VIT or any of the exam, right? So test series regarding different exams are there in this description box. You will see extra mile engineering test series is also there. So according to your own I would say what exam you are focusing on, or all the exams, you can purchase the test series as well here, right? And what are the different queries that you have regarding JEE Advanced or any of the exam, you can write it down in the comment section. Okay? Okay then, bye-bye. Take care. This is Diksha Kaushal signing off.